but I would not underestimate the difficulty of alignment of models that are actually smarter than us, of models that are capable of misrepresenting their intentions.
Are you worried about spies?
I'm really not worried about the way it's being leaked. We'll all be able to become more enlightened because we'd interact with an AGI that will help us see the world more correctly. Like, imagine talking to the best meditation teacher in history. Microsoft has been a very, very good partner for us. So I challenge the claim that next token prediction cannot surpass human performance. If your base neural net is smart enough, you just ask it, like, what would a person with great insight and wisdom and capability do?
Okay, today I have the pleasure of interviewing Ilya Sutskever, who is the co-founder and chief scientist of OpenAI. Ilya, welcome to the Lunar Society.
Thank you. Happy to be here.
First question, and no humility allowed. There's many scientists, or maybe not that many scientists, who will make a big breakthrough in their field. There's far fewer scientists who will make multiple independent breakthroughs that define their field throughout their career. What is the difference? What distinguishes you from other researchers? Why have you been able to make multiple breakthroughs in your field?
Well, thank you for the kind words. It's hard to answer that question. I mean, I tried really hard. I gave it everything I got. And that worked so far. I think that's all there is to it.
Got it. What's the explanation for why there aren't more illicit uses of GPT? Why aren't more foreign governments using it to spread propaganda or scam grandmothers or something?
I mean, maybe they haven't really gotten to do it a lot, but it also wouldn't surprise me if some of it was going on right now. Certainly, I imagine they'd be taking some of the open source models and trying to use them for that purpose. I would expect this would be something they'd be interested in the future.
It's technically possible, they just haven't thought about it enough?
Or haven't done it at scale using their technology. Or maybe it's happening, but you just don't know it.
Would you be able to track it if it was happening?
I think large-scale tracking is possible, yes. I mean, it requires a small special operation, but it's possible.
Mm-hmm. Now, there's some window in which AI is very economically valuable on the scale of airplanes, let's say, but we haven't reached AGI yet. How big is that window?
I mean, I think this window, it's hard to give you a precise answer, but it's definitely going to be a good multi-year window. It's also a question of definition, because AI, before it becomes AGI, is going to be increasingly more valuable year after year. I'd say in an exponential way. So in some sense, it may feel like, especially in hindsight, it may feel like there was only 1 year or 2 years because those 2 years were larger than the previous years. But I would say that already last year, there've been a fair amount of economic value produced by AI. And next year is going to be larger and larger after that. So I think that there's going to be a good multi-year chunk of time where that's going to be true. I would say from now until AGI, pretty much.
Okay. Well, because I'm curious if there's a startup that's using your models, right? At some point, if you have AGI, there's only one business in the world, right? It's OpenAI. How much window do they have? Does any business have where they're actually producing something that AGI can't produce?
Yeah, well, I mean, it's the same question as asking how long until AGI.
Yeah.
I think it's a hard question to answer. I mean, I hesitate to give you a number. Also because there is this thing effect where people who are optimistic people who are working on the technology tend to underestimate the time it takes to get there. But I think that the way I ground myself is by thinking about the self-driving car. In particular, there is an analogy where if you look at so I have a Tesla, and if you look at the self-driving behavior of it, it looks like it does everything. It does everything.
All right.
But it's also clear that there is still a long way to go in terms of reliability. And we might be in a similar place with respect to our models where it also looks like we can do everything. And at the same time, we'll need to do some more work until we really iron out all the issues and make it really good and really reliable and robust and well-behaved.
By 2030, what % of GDP is AI?
Oh gosh, hard to answer that question. Very hard to answer that question.
Give me an over-under.
The problem is that my error bars are in log scale. So I could imagine a huge percentage. I could imagine a disappointingly small percentage at the same time.
Okay, so let's take the counterfactual where it is a small percentage. Let's say it's 2030 and not that much economic value has been created by these LLMs. As unlikely as you think this might be, what would be your best explanation right now of why something like this might happen?
My best explanation. So I really don't think that's a likely possibility.
Yeah.
So that's the preface to
Right.
to the comment. But if I were to take the premise of your question, well, like why were things disappointing in terms of the real world impact? And my answer would be reliability. If somehow it ends up being the case that you really want them to be reliable and they ended up not being reliable, or if reliability turned out to be harder than we expect, I really don't think that will be the case. But if I had to pick one, and you tell me like, hey, like why didn't things work out? It would be reliability, that you still have to look over the answers and double check everything. And that just really puts a damper on the economic value that can be produced by those systems.
They'll be technologically mature. It's just a question of whether they'll be reliable enough.
Yeah, well, in some sense, not reliable means not technologically mature, if you see what I mean.
Yeah, fair enough. What's after generative models, right? So before you're working on reinforcement learning, is this basically it? Is this a paradigm that gets us to AGI, or is there something after this?
I mean, I think this paradigm is going to go really, really far, and I would not underestimate it. I think it's quite likely that this exact paradigm is not going to be quite the AGI form factor. I mean, I hesitate to say precisely what the next paradigm will be, but I think it will probably involve integration of all the different ideas that came in the past.
Is there some specific one you're referring to, or?
I mean, it's hard to be specific.
So you could argue that the next token prediction can only help us match human performance, and maybe not surpass it. What would it take to surpass human performance?
So I challenge the claim that next token prediction cannot surpass human performance. It looks like on the surface it cannot.
Mm-hmm.
It looks on the surface, if you just learn to imitate, to predict what people do, it means that you can only copy people. But here is a counter argument for why it might not be quite so. If your base neural net is smart enough, you just ask it like, what would a person with great insight and wisdom and capability do? Maybe such a person doesn't exist, but there's a pretty good chance that the neural net will be able to extrapolate how such a person should behave. Do you see what I mean?
Yes, although where would it get the sort of insight about what that person would do, if not from
the data of regular people? Because like, if you think about it, what does it mean to predict the next token well enough? What does it mean actually? It's a deeper question than it seems. Predicting the next token well means that you understand the underlying reality that led to the creation of that token. It's not statistics. Like, it is statistics, but what is statistics? In order to understand those statistics, to compress them, you need to understand what is it about the world that creates those statistics. And so then you say, okay, well, I have all those people. What is it about people that creates their behaviors? Well, they have, they have thoughts and they have feelings and they have ideas and they do things in certain ways. All of those would be deduced from next token prediction. And I'd argue that this should make it possible, not indefinitely, but to a pretty decent degree, to say, well, can you guess what you'd do if you took a person with like this characteristic and that characteristic? Like, such a person doesn't exist. But because you're so good at predicting the next token, you should still be able to guess what that person would do, this hypothetical, imaginary person with far greater mental ability than the rest of us.
When we're doing reinforcement learning on these models, how long before most of the data for the reinforcement learning is coming from AIs and not humans?
I mean, already most of the data for reinforcement learning is coming from AIs. Yeah. Well, it's like the humans are being used to train the reward function, but then the reward function in its interaction with the model is automatic, and all the data that's generated during the process of reinforcement learning is created by AI. So, like, if you look at the current, I would say, technique paradigm, which has been getting some significant attention because of ChatGPT, reinforcement learning from human feedback. So there is human feedback. The human feedback is being used to train the reward function. And then the reward function is being used to create the data which trains the model.
Got it. And is there any hope of just removing the human from the loop and have it improve itself and some sort of alpha go away?
Yeah, definitely. I mean, I feel like in some sense our hopes for like our plan, like very much so. The thing you really want is for the human teachers that teach the AI for them to collaborate with an AI. So you might want to think about it. You might want to think of it as being in a world where the human teachers do 1% of the world and the work, and the AI do 99% of the work. You don't want it to be 100% AI, but you do want it to be a human-machine collaboration, which teaches the next machine.
So currently, I've had a chance to play around these models. They seem bad at multi-step reasoning, and they have been getting better. But what does it take to really surpass that barrier?
I mean, I think dedicated training will get us there. More improvements of the base models will get us there.
Okay.
But fundamentally, I also don't feel like they're that bad at multi-step reasoning. I actually think that they are bad at mental multi-step reasoning, but they're not allowed to think out loud. But when they are allowed to think out loud, they're quite good. And I expect this to improve significantly, both with better models and with special training.
Are you running out of reasoning tokens on the internet? Are there enough of them?
I mean, so for context on this question, there are claims that indeed at some point we'll run out of tokens in general to train those models. And yeah, I think this will happen one day, and by the time that happens, we need to have other ways of training models, other ways of productively improving their capabilities and sharpening their behavior, making sure they're doing precisely what we want without more data.
Well, you haven't run out of data yet? There's more?
Yeah, I would say the data situation is still quite good. There is still lots to go. But at some point data will run out.
Okay. What is the most valuable source of data? Is it Reddit, Twitter, books? What would you trade many other tokens of other varieties for?
Generally speaking, you'd like tokens which are, speaking about smarter things, tokens which are more interesting.
Yeah.
So I mean, all the sources which you mentioned, they're valuable.
Okay, so maybe not Twitter, but do we need to go multimodal to get more tokens, or do we still have enough text tokens left?
I mean, I think that you can still go very far in text only, but going multimodal seems like a very fruitful direction.
Mm-hmm. If you're comfortable talking about this, where is the place where we haven't scraped the tokens yet?
Oh, I mean, yeah, obviously. I mean, I can't answer that question for us, but I'm sure that for everyone, there is a different answer to that question.
How many orders of magnitude improvement can we get just not from scale or not from data, but just from algorithmic improvements?
Hard to answer, but I'm sure there is some.
Is some a lot or is some a little?
I mean, it's only one way to find out.
Okay. Let me get to your quick fire opinions about these different research directions. Retrieval transformers. So just somehow storing the data outside of the model itself and retrieving it somehow.
Seems promising.
But do you see that as a path forward, or?
I think it seems promising.
Robotics. Was it the right step for OpenAI to leave that behind?
Yeah, it was. Back then, it really wasn't possible to continue working in robotics because there was so little data. Back then, if you wanted to work on robotics, you needed to become a robotics company. You needed to really have a giant group of people working on building robots and maintaining them and having. And even then, if you're going to have 100 robots, it's a giant operation already, but you're not going to get that much data. So in a world where most of the progress comes from the combination of compute and data, right? That's where we've been, where it was the combination of compute and data that drove the progress. There was no path to data from robotics. So back in the day, when you made a decision to stop working in robotics, there was no path forward.
Is there one now?
So I'd say that now it is possible to create a path forward, but one needs to really commit to the task of robotics. You really need to say, I'm going to build many thousands, tens of thousands, hundreds of thousands of robots and somehow collect data from them and find a gradual path where the robots are doing something slightly more useful, and then the data that they get from these and then the data that is obtained and used to train the models, and they do something slightly more useful. So you could imagine this kind of gradual path of improvement where you build more robots, they do more things, you collect more data, and so on. But you really need to be committed to this path. If you say, I want to make robotics happen, that's what you need to do. I believe that there are companies who are thinking about doing exactly that. But I think that you need to really love robots and need to be really willing to solve all the physical and logistical problems of dealing with them. It's not the same as software at all. So I think one could make progress in robotics today with enough motivation.
What ideas are you excited to try? but you can't because they don't work well on current hardware.
I don't think current hardware is a limitation.
Okay.
I think it's just not the case.
Got it. So, but anything you want to try, you can just spin it up, or
I mean, of course. Like the thing, you might say, well, I wish current hardware was cheaper, or maybe it had higher, like maybe it would be better if it was higher memory processor bandwidth, let's say. But by and large, hardware is just a limitation.
Let's talk about alignment. Do you think we'll ever have a mathematical definition of alignment?
Mathematical definition, I think, is unlikely.
Uh-huh.
Like I do think that we will instead have multiple, like rather than achieving one mathematical definition, I think we'll achieve multiple definitions that look at alignment from different aspects. And I think that this is how we will get the assurance that we want. And by which I mean, you can look at the behavior. You can look at the behavior in various tests, in various adversarial stress situations. You can look at how the neural net operates from the inside. I think you have to look at several of these factors at the same time.
And how sure do you have to be before you release a model in the wild? Is it 100%, 95%?
Well, it depends how capable the model is. The more capable the model is, the more higher the more confident you need to be.
Okay, so just say it's something that's almost AGI. Where is AGI?
Well, depends what your AGI can do. Keep in mind that AGI is an ambiguous term also.
Yeah.
Like your average college undergrad is an AGI, right?
It's debatable, yeah.
But you see what I mean. There is significant ambiguity in terms of what is meant by AGI.
Mm-hmm.
And so depending on where you put this mark, you need to be more or less confident.
Well, you mentioned a few of the paths towards alignment earlier. What is the one you think is most promising at this point?
Like, I think that it will be a combination. I really think that you will not want to have just one approach.
Mm-hmm.
I think people want to have a combination of approaches where you spend a lot of compute to adversarially probe it to find any mismatch between the behavior that you wanted to teach and the behavior that it exhibits. We look inside into the neural net using another neural net to understand how it operates on the inside. I think all of them will be necessary. Every approach like this reduces the probability of misalignment. And you also want to be in a world where your degree of alignment keeps on increasing faster than the capability of the models. I would say that right now, our understanding of our models is still quite rudimentary. We made some progress, but much more progress is possible. And so I would expect that ultimately the thing that will really succeed is when we will have a small neural net that is well understood, that's given the task to study the behavior of a large neural net that is not understood to verify it.
By what point is most of the AI research being done by AI?
I mean, so today when you use Copilot, right? What fraction? How do you divide it up? So I expect at some point you ask your, descendant of ChatGPT, you say, hey, like I'm thinking about this and this. Can you suggest fruitful ideas I should try? And you would actually get fruitful ideas.
Mm-hmm.